The Today in Manufacturing podcast offers a powerful and unique perspective on the biggest stories impacting U.S. manufacturers. Anna Wells, David Manty, and Jeff Ranke apply their experience as editors of industry-leading brands Manufacturing.net and Industrial Equipment News in providing in-depth analysis of the latest headlines. Their insight, along with a mix of humor and human interest, makes Today in Manufacturing a go-to source. Keep pace with supply chain challenges, electric vehicle developments, labor struggles, robotics, and more by listening, downloading, and subscribing to the Today in Manufacturing podcast.
Engineers at the University of Glasgow have designed, developed, and fired Ouroboros-3, the first unsupported autophage rocket engine that eats parts of its own body for fuel. The concept seems futuristic, but the idea is actually nearly 100 years old. The hope is the rocket engine can fly far beyond the Earth's atmosphere and make the United Kingdom a larger player in the space industry. The engine uses waste heat from combustion to melt its own plastic fuselage as it fires. The molten plastic is fed into the engine's combustion chamber as additional fuel that burns alongside onboard liquid propellants. Listen to this thing and watch it eat. The engineers from Glasgow, who are working with their counterparts at Kingston University, have demonstrated that the plastic fuselage can withstand the forces required to feed it into the engine without buckling. It's a key step in making the concept viable. With this technology, spacecraft would need less propellant in onboard tanks, which means the craft can be lighter or have additional payload on board. Consuming the fuselage also helps stem the growing space junk problem littering our orbit and threatening future launches. Autophage comes from the Latin word for self-eating. The concept was first proposed and patented in 1938, but engine designs using the tech were only fired in a controlled manner. That's until a team from Glasgow and Dnipro National University in Ukraine did it in 2018. In a recent test, the Ouroboros-3 engine produced 100 newtons of thrust. The tests not only show that the engine is capable of stable burn throughout the autophage stage, but also that the rocket's burn could be successfully controlled. The team was able to throttle, restart, and pulse the engine in an on-off pattern. The high-density polyethylene plastic tubing supplies up to 1/5 of the total propellant used. Now the team is looking to scale up these propulsion systems to support the additional thrust required to make the design function as a rocket. The team is focused on refining the design towards an eventual test flight, but they're unable to put a specific time frame on a potential launch. The team also declined to comment on potential commercialization efforts. I'm David Manty. This is Manufacturing Now.